microphones here, so don't sit on a microphone, but pick up a microphone and then sit down. We have 3 representatives from some of our international partners. We have directly to my left, James Carpenter from the European Space Agency. We have Naoki Sato from JAXA, and Timothy Haltigan from the Canadian Space Agency. So I think what we're going to do here, we have about 45 minutes to run this. I'm going to invite each of the representatives from our international partners to do a 5-minute overview. And then we will invite questions from the audience members of the League. If there are no people are shy, then I have some prepared questions we can use to get the discussion going. So, James, would you mind going first? Or, all right. Can we get the European Space Agency slides up, please?
Okay, thanks for having me. So my second slide is a video, which may or may not, I can't control, but yeah. So hopefully that'll work okay. Okay, I'll introduce myself while I'm waiting. My name is James Carpenter. I'm from the Human and Robotic Exploration Directorate in the European Space Agency, based in Noordwijk in the Netherlands, at ESTEC, which is the technical center for the European Space Agency, our largest center based in the Netherlands. So we are working on preparing and implementing human and robotic exploration program. So we have human and robotic in the same program as one thing, working as much as we can to do synergies between those things. Great, so go to the next slide, please. I would like to start with some hardware that we have delivered, right? So this is the European service module integrated into the Orion vehicle with US crew module here at Kennedy Space Center. So this is European flight hardware for Artemis 1 delivered to NASA and integrated, right? So we are an international partner. We are already working on and involved with Artemis. We are delivering hardware, and we're very proud and excited to be supporting what is an extraordinary program. We're looking forward to getting back to the moon with you and helping you to get there too. So go to the next slide. So this is a movie. Maybe we could run it. And I don't know if there's sound. Okay, there's no sound. You should be glad there's no sound because it's very, very loud, right? But maybe if we could skip through a couple of times. So this is the, maybe you could just skip through a few seconds, just so you can, okay, fine. Anyway, that was the European service module being tested at White Sands. If you run the movie through, we have a lot of different engines firing and operating together. I'm told it's the most complex propulsion system ever created. But they would say that, right? But it's cool to see this thing built and delivered and operating and waiting to go to the moon. So that's some stuff that we've done with you. We're looking forward to the flight of that. And now we are at a critical point in our program. So at the end of this year, well, actually in November, so not long from now, we have something called Space 19 Plus. And so we have a 3-year cycle for our budget in European Space Agency, where every 3 years, the ministers in the governments responsible for our budget in our 22 different member countries, you think your lives are complicated, for having 22 governments to keep happy, right? So they all get together and they have like a big fist fight and decide what kind of money is going to go into our program and who gets what. And so for exploration, this is the program that we are proposing. We have 4 we call cornerstone campaigns. So that's humans in low Earth orbit, primarily on space station. We have humans beyond low Earth orbit, lunar robotic, and Mars robotic. So Mars robotic is primarily Mars sample return as a new element. And we have the ExoMars mission, which is prepared to go now. For humans beyond low Earth orbit, we have future European service modules for Orion to be prepared for delivery. We are preparing now our contributions to the Gateway. So we have, at the moment, we're going through the system requirements review for the international habitat for Gateway. We're also looking at providing communications and refueling capabilities for Gateway. And we would be looking to start some of the activities preparing for support to human exploration at the lunar surface as well. terms of lunar robotic, we are looking at preparing payloads for science and technology preparation. We should be looking to fly on missions with international partners. We don't at the moment have a European lunar lander, so we're working already with NASA, particularly with Steve Clark and Ben Bussey and SMD, to look at how we can contribute to the objectives of the CLIPS. And we actually already now are providing hardware for CLIPS on the first task order to the Prospect Ion Trap Mass Spectrometer instrument, which Barbara Cohen from Goddard is leading. And so we're very excited to be the first international partner, if you like, to be providing hardware for CLIPS flights. We're going to investigate, we're also preparing something called Prospect, which is a package for looking at resources in the lunar polar regions. That's going to be drilling down around a meter, taking samples that could contain water, ice, and other volatiles, heating those things up, but also introducing some reactants to those samples to see if we can extract some minerals. We're also starting in earnest in situ resource utilization as a new area of interest for us. We've heard several references to the Lunar Resources Workshop that we had as part of the Luxembourg Space Resources Week just a couple of weeks ago. This is an incredible area where 2 years ago, nobody in Europe was doing anything in space resources, apart from a few isolated pockets of activity. 2 weeks ago, we had a meeting in Luxembourg. We had 370 people and a waiting list to participate. Right? That's extraordinary progress. There's a huge amount of activity going on, and some of it we're doing, and some of it is being done elsewhere. But it's a tremendous momentum. We now have to turn that into real money, right? That's the hard part. So, and then in parallel with these different areas, we'd also be looking in robotic at developing a cargo lander capability. We should be looking to maybe do that with international partners to support Artemis. And deliver payloads up to 1.5 tons to the lunar surface. So that's something we'll be studying. So in this program for 3 years covers us from 2021, 22. So it'll be things we're committing to fly in that time, but also the preparatory work in terms of studies and technology activities to allow us to take decisions on the next elements, which will be in 2023, or the end of 22, sorry, and it'll cover us for 23, 24, 25. And in parallel, we have Expert, which is the technology and system studies part, and SciSpace, where we now try and bring all of the scientific utilization of these capabilities, whether it's Mars, humans in LEO, humans beyond low Earth orbit, or Moon, and we manage that all from a single place where we try and coordinate that science and try and identify synergies and opportunities to do things. There's a lot of science you want to do at the lunar surface, which is tremendously synergistic with things you'll do in deep space at the Gateway, things you'll do on low Earth orbit, and things you might do at Mars. We try and bring that competency together and create an integrated approach. So we're very excited and not just a little bit nervous about what's going to happen in the next 3 weeks. The decisions that they make are going to affect the kind of role that we can play in an international lunar exploration program, because I think this is something that we as a species have to do together, even if you're all leading the show. And the final slide, just not quite the next slide, please. Two things we're going to be implementing. We have 2 strategies we produced. A strategy for science at the Moon, which says the things we would like to accomplish at the lunar surface in terms of science by 2030. And we have a strategy for space resources, saying things we'd like to do in the next 10 years to prepare for space resource utilization, doing things in space, but also creating benefits for Earth. Those 2 things are both online. Google them, you'll find them, download them, read them, agree, disagree. But I think we're all in agreement about what needs to get done. And finally, our program is all, next slide, please. Our program is all about working together. So it's about partnerships. It's about partnering between robots and humans, as you see beautifully illustrated here. It's about partnering between internationally, Europe, which is ESA, which is an organization built on partnerships, partnering beyond that with NASA and with others. And it's about partnering between science and technology, between exploration and science, and making sure that we do this for everybody's benefit, because I think we're all going to benefit internationally from what's coming. Thanks very much.
Hello, I'm Naoki Sato of JAXA, Space Exploration Center. So I'd like to talk about the JAXA's plan and the vision for the space exploration. Okay, next chart, please. So this is the, I'd like to, first of all, I'd like to talk about the very big news from Japan. This is not fake news, but I'm sorry, but it's really real true news. Next chart, please. So just 10 days ago, the Japanese government formally decided to participate in the international space exploration, including the Artemis program. Next chart. Yes. So basically for the 4 areas, next chart, please. So the first one is to participate in the gateway, actually providing some components such as the ECRUS or TCS subsystems. And the second one is, next chart, please. Yes. And the second one is some moon surface data sharing with international partners. So actually, we are going to the moon by SLIM 2021 timeframe, and also the South Pole moon exploration in 2023 timeframe. So we will gather several data, including the resource data. So we are going to share these data with international partners. And third one is the logistic missions to the gateway using the HTBX and the H3 Japanese rocket. And the fourth one is the I have to the gateway. We are collaborating with ESA, so this international habitation module, and also the other big pressurized module or unpressurized module. So we have decided to contribute from these 4 areas. Next chart, please. So this is overall JAXA space exploration scenario for Mars. We have just only an MMX project, but we are also studying about the following missions after the MMX. For the moon surface, so the SLIM is the first. This is a pinpoint technology demonstration mission. And next one is the lunar polar exploration in around the 2023 timeframe. After that, we also considering another big lander project cooperating with CSA and ESA. And after that, this should be the sustainable human lunar exploration and utilization, utilizing some reusable system or such a rover or lander. For the lunar orbit, we are launching some 2 CubeSats launched by SLS Mission 1. And also we are studying about to launch some small mission to the lunar orbit by Epsilon rockets. And after that, the gateway will be the next place to be contributed by Japan. And we talk about, I'm going to talk about the SLIM a little bit more. Next chart, please. Yes, so the SLIM is a demonstration of the pinpoint lunar landing technologies. Our target of the accuracy is 100 meter. And also we are bringing some small scientific payload, such as mineralogical investment. And also the next one is the lunar polar exploration mission. It's still under study. The primary objective is to obtain the knowledge of the water resource or distribution on the moon. Target launch date is 2023. And we are going to land some sunlit, rich sunlit area, and go down to the water abundant area, and the drills takes some regolith and heat, and they investigate how much water is in the regolith. So, but this is not only the scientific mission, but we are going to demonstrate some lunar surface traversing technology by the rover. by the way, this is a joint mission with ISRO, India. So ISRO is providing the lander, and JAXA is providing the rocket and the rover. I think that's it for my presentation. Thank you very much. Finally,
good afternoon, everybody. I'm really glad to be given something that I didn't have to pull off that was glued, so thank you for that. My name is Tim. I'm from the Canadian Space Agency, from the Space Exploration Directorate, and just from a personal standpoint, I'm really glad to be here. This is my first LEAG meeting that I've attended, and it's been fun to watch such a vibrant and certainly vocal community in action. So it's really fun to be part of that, and I'm glad to be representing CSA here. What I want to do really is, obviously as the Canadian program, we're a lot more modest than, our neighbors to the south, and certainly our international colleagues. So you can think of this really as sort of perspectives from the little guy. Now, that being said, we really are trying to make meaningful contributions in the places that we can. So what I wanted to do today was just give a quick overview of some of the activities we're undertaking, how the program is being built, and identifying some of those opportunities that we may have to work together. So, first things first, the good news, Canada is going to the moon. We've been given a directive from our federal government to participate in international lunar exploration initiatives. So obviously the big ticket item is that we will be providing Canadarm3 to the Gateway. So a piece of technology that's obviously been critical to ISS construction and operations, we're now expanding and putting new capabilities on to become part of the Gateway. So this is really a major initiative for our technical community. Now, as part of the investment that's being made by the government, they've also carved off a bit of money for science and technology development as well. And this is called the LEAP program, or the Lunar Exploration Accelerator Program. So to talk about that just very briefly, basically we've been given $150 million over the next 5 years to build things quickly, to get them to the moon, and to demonstrate not only technological capabilities that we're going to need for future missions, but also to put together some payloads to demonstrate really good science right now. So here we have an opportunity for Canada to really put together its first payloads to the moon. We've explored asteroids, we've explored Mars, but this is our first chance to really get our science teams to the moon. So we're tremendously excited about this. In terms of the types of initiatives that we've been asked to undertake as part of LEAP, there's a health initiative, which is going to look at long-term spaceflight, but also translating some of those technologies to remote communities as well. So using space almost as a demonstrator for terrestrial health initiatives. Secondly, robotics and technology. So again, these are tech demonstrators that we would need to fly now in order to enable some of the bigger missions later. And finally, the scientific payloads. So in terms of the scientific payloads and trying to understand what our priorities are, recently we've gone through sort of the Canadian equivalent of the decadal process. So this is a process by which we survey our entire community and try to collate all of the exploration themes that our community is trying to tell us to pursue. So from a planetary science, it's sort of been broken out into 4 themes: astrobiology, planetary atmospheres, geology, geophysics, and prospecting, and the planetary space environment. Now, of those, 3 obviously have direct applicability to the moon, and so this is a report that's fully public, and so this is a great way of sort of showing the world what the Canadian priorities are and how they can map to international priorities as well, and try to identify some of those places for collaboration. In terms of the geology, geophysics, and prospecting theme, that was led by Gordon Azinski, who many of you know. And the key here is the word prospecting. The last time round it was simply called planetary geology and geophysics, but I think as one of the themes that I've really seen emerging over the last couple of days is this importance in early prospecting. And so just know that your neighbors to the north are thinking about this as well. Again, so the whole goal of this document is similar to the decadal in terms of prioritizing the investigations and telling the CSA what types of investments it needs to be making early in order to realize those objectives afterwards. So with that being said, how can we work together? I think there's a number of opportunities that we're trying to carve out programmatically. Obviously, the first and biggest ticket item for us would be full payloads with science teams associated. So if there are opportunities to develop and fly some of these with you, that's something we're certainly willing and excited to talk about. In terms of technology contributions, this can be, you can think of it as a range of possibilities. First from, demonstrating critical technologies that you need to fly, but also thinking about Canadian components that may become of the supply chain to international payloads as well. So if there's a particular Canadian component that is excellent, and there are several, we have ways of being able to contribute those. And finally, science team members as well. So in some cases, it's a lot easier for us to put a Canadian scientist on an international team than it is to contribute an entire payload. So what we're putting together is participating science programs, planetary co-investigator programs, and potentially extending even out to survey, trying to put Canadian scientists on survey teams so that they can participate in some of those early activities as well. So the bottom line, we're excited. We have some resources to use. I'd like to use them, and I'd like to work with you to use them properly. Thank you.
All right. So I think everybody has a microphone. Take one, pass it down. Do we have any questions from the audience? We heard about a kind of a neat variety of collaborations and potential collaborations. Does anybody want any more information on any of those or any other questions? All right, well, let me start with a question. Tim, at the end of your talk, you mentioned the potential for Canadian guest investigators and in American programs. Actually, I'll say I have 2 Canadian team members on my survey team, and they're doing awesome work already. But what about for missions that your agencies are leading? As in the past, we've had American guest investigators on your missions. Is that something you see in terms of cooperation in the future for guest investigator programs or foreign instruments on your missions or proposed missions?
So is this on? I'll take the one that's working. So first off, I would love to be in the position to be flying my own missions in order to entertain those thoughts. That being said, for the payloads that we potentially would be putting up, certainly you can envision international participation on, whether it's through a guest investigator or part of the core science team as a co-I on the instrument itself. That's a possibility. So I mean, there's certainly a lot of mechanisms available to do that.
Great. What about from JAXA and USA?
For the SLIM mission, we are developing. I think this is the technology demonstration. So I think only the small Japanese science payload is going to be launched. So currently there is no opportunity for the international collaboration, but for the resource prospecting mission, I think we have some. International payload, and also we have some opportunity for the maybe the national AO, but some scientific payloads can be launched.
Thank you.
So for ESA, again, we don't have our own mission at the moment. We have payloads that are being prepared. So if I take the Prospect, for example, we recently put together a Prospect science team. We have US participation in that Prospect science team. As a principle for exploration, everything we do is in cooperation, international cooperation. That's one of the reasons we've been told that we do exploration in ESA, and so that's a big part of what we do. So I think we have, as a principle, we would try to create opportunities for international participation in whatever we do.
Thank you all. We have some questions.
This is Laura Kerber from JPL. First of all, I just wanted to say how exhilarating it was to see beautiful hardware connected and delivered. And I'm just so pleased that, the international community and the US is working on this project together, and just so pleased to see all of the contributions that you guys talked about, first of all. And then my other question was, could we as a community help make that easier for you guys to do? Is there information that you often find is lacking, or a structure that you think would better make it easier for you guys to convince your governments or your agencies to participate in things?
So I've got the mic, so I'll go first. So first of all, thank you very much. I also think it's fantastic to see actual hardware getting delivered, right? It makes it kind of feel real. Right? So I think one thing that's been, I think, challenging for us in the last year or so has been the rate of change. So the US is leading this. We have a 3-year cycle to what we do, and we have certain processes and ways of doing things. We are not used to moving very fast. And so this is one of the things I'm actually quite enjoying, though it's painful, is to be challenged by the pace of things and to how can we respond quickly. And so we're having to reinvent some stuff to make that work. That's one challenge. I think our stakeholders at political level are going to have to take some decisions very soon. So anything that is about giving at that kind of level people visibility of what is happening, visibility and understanding of the value that it delivers, and confidence that it's something that is real and is worth investing in, and to help them understand that we have a 3-year cycle. If we miss this window to participate, then we have missed the window to be a serious contributor to get those benefits. I think they need to understand that. On the science side, something that I have found in Europe is that our science community is often not very visible to the decision makers at political level. They often are not aware that there is a science community or the outstanding work that they do. And one thing I've enjoyed very much about coming to the US over the last years is seeing how proactive the community is here, saying, well, this is what we want. And to get it, we have to go out and get it. And there's a certain impetus on us as the community to do that. And I think in Europe, sometimes that isn't quite the same. There is more of a tendency to sit back, wait and receive what's given to you and then grumble when you don't get it. So I think that we've been trying to encourage the community in Europe to, if you want something, make it clear, be visible. And so any support you can give to that kind of initiative can be helpful.
If I could just take the other mic. If I could just pick up on that for a second. James is absolutely right. It's difficult sometimes to be reactive, especially in government. And so when you think, at least from our perspective, you need policy coverage, budget, and opportunity, and this magical Venn diagram to intersect, and that's the time that we're able to fly something. And obviously, from an international standpoint, you can't influence our policy nor our budgets, but you can identify opportunities. And so the longer ahead that you identify Canadian capabilities that would be valuable as a contribution, and as James says, be vocal about it. If there's something that you believe that would be critical and valuable to you, tell us. And tell us loud and tell us repeatedly, because sometimes it takes a little while for the message to get through, but it just simply identifying those opportunities and trying to sort of see where those niches may be is hugely valuable.
Okay, thank you for the question.
Dana Hurley, APL. Can you talk about what your plans are for archiving the data from your experiments and collaborating on analyzing those?
From our perspective, my understanding is that Canadian payloads flown would work with the PDS to archive publicly. As with most missions, I think the science team would get a short proprietary period with it, but I think the intent is to make it fully wide open. There's also a nationwide initiative for Canadian science called Open Data. And so whether it's through the PDS formally or through some Canadian server, the goal is absolutely to make it publicly and widely available.
Yeah, I think in Japan is the same situation. So we are sharing the data from the any scientific or exploration payloads. So, and we are sharing the scientists and also the industries.
So in ESA, we have a data policy for all science that it should be made available to the community at large. There is normally a proprietary period for PI or science team, after which products should be released. We do that through something called the Planetary Science Archive, which is a little like the PDS. The data standards that we use are equivalent to PDS normally. And so yeah, there's data is always made publicly available, and there's people to support you in getting hold of that data if needed. Now, for some things where we're perhaps partnering with NASA on a payload, then you could also consider that data might be mirrored on PDS or vice versa, but that's the plan.
Thanks.
John Gruner, Johnson Space Center. Two questions, one for James and then maybe one for both James and Sato-san. James, a year or so ago, ESA did a solicitation for a ISRU demonstration mission. I was wondering if you could give us an update on that. And then in the JAXA slides, Heracles was still on there, so I was wondering if we could get an update on what the different agencies are thinking with Heracles still.
So regarding the ISRU demonstration, we still think, if you read our strategy document, you'll see that there is a chicken and egg situation with ISRU where you can't plan it into your architectures because no one's showing it's possible, but nobody will invest in showing it's possible because it's not designed into anyone's architectures. So how do you break that paradigm? We think you break that paradigm by showing you can produce something useful on the moon. And once you've done that, nobody can ever tell you it can't be done again. So we would like to have the demonstration of the production of, we say, water or oxygen at the lunar surface in the mid-2020s. We have a number of parallel streams now of activity in terms of system studies and technology activities to work towards that. We are looking currently at 3 different processes for mineral reduction at the lunar surface, which perform quite differently. We're looking at both the performance of those processes and the implications of using those in a space system. And we'll be looking at the Ministerial Council meeting this year for the budget to continue the development of that. So we've just gone through the PRR, Preliminary Requirements Review, of the system studies for the demonstrator. On Heracles, we have recently went through an international programmatic review to look at that, because when we started Heracles also, I mean, Artemis wasn't there, so to understand how that fits into the whole scheme of things. One outcome of that was that we should look at the cargo lander or a logistics lander as a capability for Artemis. And we are currently looking at a scientific mission concept that could go on the first mission of that cargo lander, potentially. And that would probably look a little bit like the Heracles mission that we were studying previously. There'll be some implications to that. So Heracles was driven very much by exploration requirements linked to demonstrating some of the technologies that could be used on the human missions to come later. The acceleration of Artemis means some of those demonstrations would now become obsolete. So that reframes things a little bit, and we're currently working to understand what the next step should be in terms of that particular mission scenario. But however we take that on, that'll be something we continue to want to do in international partnerships with JAXA, CSA, and with NASA.
Yeah, I think basically the framework of the Heracles is not changed. So the ESA and the CSA and also the NASA working with us. And maybe the role sharing of the Heracles may be changed from the original idea. But anyway, the framework will be the same. And also the Heracles is not only one mission. So the first mission will be 2027 timeframe. But we are thinking some cadence of flight per year. So maybe the first one is maybe it could be just a payload or logistic capability, but the second or third or fourth one could be the scientific mission.
Okay, thanks. Because if you guys noticed earlier, we're having a trouble with Artemis getting much cargo return back from the moon, and a 1.5-ton lander could carry an ascent module with plenty of sample in it. So that would be a great way to fill in getting science samples back to Earth using the Heracles as that system.
Yeah, that is the original option, and that option is still kept.
Yeah, Clive Neal, Notre Dame. Interesting, each one of you talked about prospecting or having payloads to be able to identify resources. Has there been any consideration, or has there been any talk or cooperation with the Viper project to actually start getting an international campaign going on this issue? Because it's something that's really needed, and it seems as if the pieces are coming together nicely with the expertise, with the instruments, and now hopefully with rovers. But has there been any thought about having this international prospecting campaign?
Yeah, I think that's a very good idea, and that is really what we'd like to talk with you this this time. So yeah, talk it later. But anyway, the campaign with the international partners is a very good idea, and I think that there are many sites to be explored. So one mission is not enough. So I think the international partners. The campaign is a very good idea.
I know there have been discussions. I'm not sure what the outcomes of those in terms of hardware and systems. Certainly this would be an opportunity, I would hope, for the Viper science team to open up to that international collaboration, because there would be ways of putting scientists on the team. And I mean, from my perspective, if anyone's going to find ice on the moon, it should be the team that brings skates with them. So certainly would love to be part of that somehow.
Yeah, so I think all of us are investing in some way in studies, technologies, payloads that can support prospecting. I think that's both in terms of the polar regions, so we're developing Prospect at the moment. We've also had studies going on to look at what kind of instrument suites you want to take somewhere else. So we're interested particularly in things like pyroclastic deposits and to understand what's there, both from an oxygen production, but also what kind of materials might you be able to produce in some of these locations too, as a bit further down the road. So prospecting can be something that is polar, it can be broader than that. I think if we pool our investments together and we coordinate what we're doing, then I think we can achieve an awful lot together as an international community. Within groups like ISEG-G, this has been discussed previously. So we started some work some years ago even on trying to understand how that might look. LEAG also supported that. And I think programs like the CLIPS program create an extraordinary opportunity to really start to realize this. So I commend CLIPS. I think it's an outstanding program. I wish we had one.
So I was just going to add to that. There are two activities going on. One is through the ISEC-G. We have an ISRU gap analysis team, which is looking at the strategic knowledge gaps, all the work that's going on across the different agencies, and we will come back to ISEC-G management with some recommendations, prospecting being one of those. The other is there's an in-house NASA activity kind of going on right now. I was hoping they might have had something ready for this particular conference, but they are, it's a team looking at what measurement capabilities are needed for resource economic analysis versus necessarily just science, what measurements are needed and such. So hopefully both of those by early next year will be publicly available.
So just to pick up on some of these points and something James raised, is the notion of coordination. I think one of the themes that's been bubbling up again over the course of the week so far has been one of campaigns, that a single mission won't necessarily give you all the information you need. And so I don't think anyone here believes that one nation or one agency can take care of all of those missions themselves. And so in terms of really getting down to identifying who can do what and how in the big picture we can all figure out the bigger questions, I think it's going to be tremendously important.
And yes, so also the ISEC-G is working on the ISR gap team, and also we have worked on some collaboration mechanism for the lunar prospect mission with the support of LEAG. And at the ISEC-G, we have a GR3 version, and we are now updating the GR, incorporating the more ISRU activities. And the target date will be the summer time frame next year. So I think for the various international cooperation, I think some united grid, some scenario is very important. So that's why we are working on that kind of scenario at the ISEC-G, and we are very pleased to have some updated mission scenario on the lunar surface in the next summer timeframe.
And maybe just to say, I've been really excited in the last months to see the emergence of Viper and Prime One. I think those are an amazing way to get this thing started, to set precedent, create the technologies, create the science team, build some momentum, and get some really important data. So I think it's absolutely fantastic. That's really starting now.
I'd, in the last 5 minutes that we have here, I'd like to kind of pick back up on this idea of campaigns that Tim mentioned and Clive mentioned earlier. I mean, we spent all day yesterday talking about starting to set our priorities for the next decade of lunar science. We heard today about the human exploration architecture that's going to get us there to help us carry out that science. And so, if we're thinking about a sustained presence of lunar surface operations, and given the resources that our different agencies have, how do your agencies and the leadership go about prioritizing or working with the scientific and technological communities in Europe, Japan, and Canada to prioritize where you invest and how you go about investing those kind of precious few dollars or euros or that you have?
So the first thing we do, I think, would be to understand the international context. So, which is driven very much by the US. So what are you doing? Where are you investing? And what opportunities do we see there? So one of the things, for example, we are working, I mentioned earlier in a comment, is working with the private sector to develop a communications relay capability around the moon. The intention is to have the first communications satellite called Pathfinder launched hopefully in 2022. And then to develop over the next decade a constellation of communication satellites which we can use to support the international lunar surface activities. And that's something that we can, I think we can realistically do in that time frame that can make a real difference to what's possible on the surface and where we can really add some value. Also looking at this logistics lander as a way of supporting that, and there are other things we're looking at too. The second thing that matters a lot is what does our industry want to do? So they also have a big say in where their interests are, what they're interested in investing in, and where they see their capabilities can come forwards too. So it's about a combination of international context, our own strategic interests, and industry's drive and what they're advocating for.
In Japan, I think there's two ways, and the ISRU matter is a little bit different things. I think it's not a pure scientific matter. So, but ISRU itself is very important for us too. So we in Japan, the ISRU is a very high prioritized technology development area. And for the science, I'm not a scientist, so I cannot speak for so much about the science. But basically, the science is a kind of the competition matter. So for the science, I think the science community, Japanese science community, will determine what is the science priority.
From the Canadian perspective, we're very reliant on our community and getting feedback from them. So I introduced the Space Exploration Workshop, or our equivalent of the Decadal, which is where we get the entire community together to define some of those big picture questions. From an implementation standpoint, though, we've got industry and technology consultation committees and also science planetary exploration consultation committees or advisory committees that we work with continually to make sure that as we refine our priorities, it's consistent with what the community wants and needs, and frankly, consistent with what the community can develop. Because again, as a smaller program, we've got a necessarily more narrow set of expertise. So it's really a question of honing in on that expertise and refining it to make sure that it is the best in the world for that particular element. So things like robotics and optics certainly are things that come to mind for Canada.
Just maybe on the science, which I didn't touch on. So we have a science strategy now and a strategy for space resources. In both those cases, we consulted with the community. The science strategy was quite easy, actually, right? Because you worked it all out. What we didn't do was a massive community consultation, say, what science do you want to do on the moon? Because it's been done, and it's been done, and it's been done. And so what we did is we took all the documents that have been done already, especially the SCEM document from 2007 and things that have come more recently, also from Europe, and we said, has anything changed? And there were a few things that maybe there were updates, but then that came the basis of what we said we want to do. For space resources, we had a first workshop just over a year ago, and we said, right, what have we got in Europe? And where do we think we want to go? What are our strengths? What do we think needs to be done? And we tried to consult with the community on that. And then we brought it back to them again a few weeks ago and said, do you still agree with this? Are we going in the right direction? The answer was yes. And so with both of those things, we have a principle that we come back to those strategies on a regular basis and say, does it still apply? What has changed? Because one thing we have realized is everything is changing very, very quickly, and we mustn't get too stuck into one set of priorities or one direction. We need to be ready to adapt and change as the truth on the ground is changing.
I think that's a great place to end there. Let's please thank our representatives from our international partners. One more time.